Hello, Calculus. Hope you're having a fantastic day. Today we're going to be talking about evaluating using U substitution. Now, evaluating integrals means you're working back with definite integrals. So if you notice, we go from 0 to 1, all that jazz. For the first portion here, I'm going to evaluate it just like I would using regular good old U substitution. I'm going to zoom in just a little bit here so you can see this a little bit better. That's not zoomed in. Focus. There we go. So I've got x to the 5th over x to the 6th plus 1 cubed. So obviously my u is going to be x to the 6th plus 1. du will be 6x to the 5th dx. And I've got x to the 5th and dx here. Here's my u. X to the 5th and dx I've got, but I don't need this 6, so I'm going to get rid of that. Alright, so we can rewrite it now as the integral of, let's call this u to the negative 3 and go ahead and bring it up. And du, and I'm going to take this 1/6 and I'm going to put it outside. Goes outside the integral. It doesn't belong here. But this brings me to the new portion of this, which is the limits of integration, your bottom and your top of your integral. Now back over here, this was dealing with x. But now I'm dealing with u. And in case you're not familiar with the alphabet, x is not u. And that usually means that you have to change it. So 0 and 1 are my x values. What I'm going to do here is just make a little chart. 0 and 1 are my x values, and I need to change them into u. So I'm going to go to what u is, and I'm going to plug it in here. If I plug in 0 to the 6th power plus 1, right? So my 0 power, 0 to the 6th plus 1, I get 1. About a 1. 1 to the 6th power plus 1 is 2. So my new units of integration, instead of 0 and 1 for x, are going to be 1 and 2 for u. So I want you to write a little asterisk here. Oops.
Attention students, if you
Must
are a choir
find.
member and need to pick up your fundraiser stuff, please go to the choir room now to pick it up. Thank you.
Go to the choir room. Must find LOI, limits of integration, for u. That's what this is doing here. And now I can go through and just go through and figure out what this is going to be. So remember, with definite integrals, we don't worry about a plus c. So let's go ahead and integrate. I've got 1/6 times, this will be u to the negative 2 over negative 2, evaluated from 2 to 1. I'm going to come through and simplify this just a little bit here. I'll have, let me see, if I multiply my 1/6 through, well, never mind. Let me leave it like this. 1/6 times 1 over 2u squared. I'm going to make that whole thing negative. And I'm evaluating that from 1 to 2. Okay? So let's figure out what this is going to be here. Pulling this out, I got a 1/6 here. Oops, excuse that. Let me put the 1/6 where it needs to go, outside of the brackets. 1 to the negative 2 u squared. So plug in your 2, f of b. So this will be, what will this be? 2 squared is 4 times 2 is 8, so negative 1/8. Minus, here's f of b, minus f of a. Plug in a 1 here, it'll be negative 1/2. Which is 1/6 times, let's see, I've got 1 over 8, so this will be plus a half plus 4 over 8, so 3/8. Right? So 3/8. Multiply these out, I've got 3 over 6 and 8 is 40 some odd. 50 some odd. Good Lord, I can't think. 48. Good grief. Where's my mind? And I'm pretty sure I can simplify that. Actually, you know what? I could have simplified 3 and 6 into 1 and 2 and just called this 1 over 16. Either way, there it is. Oh, wow. Sorry. 1 over 16. Okay, so pretty standard stuff. The only thing that's different now is that I can just plug these straight into U, and this lets me kind of skip plugging U back in. So it's really, really handy. All right, example 2, 0 to pi over 12 rather, of sine of 3x. So the first thing I need to identify is my U, which is 3x. So du is 3 dx. Divide by 3, which is 1/3 du. So I'm going to change this to the integral with my 1/3 out front. This is u, and du is 1/3 dx. So this is going to be the sine of u du. 1/3 out front. And now I need to figure out what my u integrations are, my limits of u integration. So x and u, I'm going to make a little table here, going from 0 to pi over 12. Well, if you plug in a 0,
Attention
good
in the
Lord.
building. Randy, Eli, your right is up front. Randy, Eli, your right is up
3
front.
times pi over 12 is 3 pi over 12, which is pi over 4. So I'm going to make this 0 to pi over 4. So remember, the only thing I'm changing here, really, is making my limits of integration in terms of u. So plug them into u, see what happens. 1/3. And the integral of sine is negative cosine u, and that is going to be evaluated from 0 to pi over 4. And again, what this allows me to do is skip the whole plugging back in for u, plugging u back in. I don't need it. So let's see here. It's going to be 1/3 f of b, so this will be negative cosine of pi over 4. Cosine of pi over 4 is the square root of 2 over 2 minus a negative cosine of 0 is 1 which is 1/3 times. Now I've got a negative square root of 2 over 2 plus 1 basically, so plus 2 over 2. Right? So that leaves me with a negative square root of 2 plus 2 over 2, combining your fractions there. And then multiply your 6 through, and that's going to be blah, 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 negative square root of 2 plus 2 over 6. I'm sorry, not your 6, but your 3. And there you have it. Or you could call it 2 minus the square root of 2 over 6, whatever, floats your boat. Okay? Now let's get into something that's actually going to require some work. Number 3. The integral from pi over 4 to pi over 3 of this monster. Well, the first thing I'm going to do here, I see, let me kind of separate this. I see that the integral has a plus sign in here, so let's go ahead and split it up for a second. Yeah, let's split this thing up. I'm not really digging the way that this is written. So it's the integral. So I'm going to split it right here. I've got a 4 right here. So technically I could call this, skip a couple steps here. 4 times the integral of sine 2 theta plus 6 times the integral of cosine 3 theta. And this is all d theta. Right? And then put your limits on there. Pi over 4 to pi over 3, pi over 4 to pi over 3. I know what you're thinking. Mr. Ballard, I don't understand. Okay. All I'm doing is splitting up the plus sign into two integrals. That's how integrals work. So splitting it up into the integral of this plus the integral of this. And then I've got my coefficients that I can pull out because they're not going to change anything. So that means I'm going to have to do two u substitutions. The first one from here. So I'm going to call u 2 theta. So for this one, du is going to be 2 dx, right? 2 dx. And I am missing a 2 outside of this thing. So I'm going to need to compensate by dividing by 2. So this is 1/2 du. There we go. So I'm going to rewrite this really quickly here. We have the integral. We're still doing, oh, you know what? Hang on. Yeah, let's do it. For the integral of sine of u and d theta, I put dx instead of d theta. Have I been doing that this whole time? No, okay. D theta. D theta is going to be 1/2. So I need my 1/2 here as well. Okay, so I'm going to put a 1/2 right here, 4 times 1/2, and there's my d theta. Now, I'm not quite finished with this integral because I need to find my limits of integration, so I've got my values for theta and my values for u. So if I plug a pi over 4 in here, in for u, plug a pi over 4, you get 2 pi over 4, which is pi over 2. And then plug in a pi over 3, and you get 2 pi over 3. So I'm going to add those new limits of integration. Let me zoom in so you can kind of see what I'm doing here. So this is pi over 2 to 2 pi over 3. Plus, now I'm going to go over here to this side. Now this guy, if I do another u substitution, again, going back to the alphabet, u cannot mean two different things in the same question. So I'm going to call this one a w substitution. I'm going to call this one w is 3 theta. Right here, 3 theta. All right, so my dw is equal to 3 d theta. And compensate because you don't have a 3 outside of cosine, so 1/3 dw equals d theta. So this is going to be the integral. Oh, and I keep not leaving enough room for some reason. I've got 6 times my 1/3 times the integral of cosine of w d theta, or dw, excuse me. All right, so what I've done is changed everything from u and w, blah, blah, blah. Let me back up here. I need to find my new limits of integration here on this one. So we have theta and w, pi over 4, and pi over 3. Plug pi over 4 in here, we get 3 pi over 4. Plug pi over 4 in here, or pi over 3 in here, and we get pi. So this is from 3 pi over 4 to pi. And I'm so sorry this is so scrunched up here. It's kind of hard to differentiate the lines. Let me see if this will help. Maybe. Separate my scratch work so you can see this hen scratch on here. Okay, so let's simplify this a little bit. 4 times 1/2 is 2, and let's evaluate the sine of u, and this is d theta. I did d theta again, and I meant du. People are screaming, I know. So the integral of sine of u is negative cosine of u, and that's evaluated from pi over 2 to 2 pi over 3. plus 6 1/3 is 2. The integral of cosine is sine, so sine W. Wow. Sine of W evaluated from 3 pi over 4 to pi. All right. I'm going to try and squeeze this in here. I hope I have enough space. I've written kind of big. But setting this up, we have 2 times negative, the cosine of 2 pi over 3 is 1/2. Negative 1/2. Minus the cosine of pi over 2 is 0, so that makes that easy, thank goodness. 2 and the sine of pi is 0 minus the sine of 3 pi over 4 is a positive square root of 2 over 2. So this is a positive 1/2, so this is going to be 2 times 1/2, which is 1, plus 2 times the negative square root of 2 over 2. 2's will cancel, so this is a negative square root of 2. 1 minus the square root of 2. Holy moly. Whoa! Captain, that's pretty crazy. Okay, so follow through with what we did here. We split it up, and then from then on, it's just treating it like it's one question. Sine of u, nothing changing, nothing unfamiliar. Same thing over here. Splitting it up, setting it up just like it's a regular u substitution. The only difference is I can't call this one u because, well, I've already used it. But the math from here down is pretty simple. Okay, we'll play around with some more of these. Don't worry about them. We will play around with some more. This next portion is more of just a kind of like a get to know me kind of section. Even in odd functions, it says let f be integrable on a closed interval -a to a. If it's an even function, now remember, even functions, forget this, mean that it's symmetrical across the y-axis, right? Like the sine wave is an even function, or excuse me, not the sine wave. The cosine wave, right? Semicircles, a parabola, that's just on the origin. If it's an even function, then what this is saying here is that the integral from -a to a is the same thing as twice the integral of 0 to a. See, what they're saying is that the area of this entire thing, if it's even, should be the same thing as if I cut this in half and multiply this area by 2. That's what this is saying, if it's an even function. If it's an odd function, then you see how this side will be positive, this side will be negative. Odd means it's an origin symmetry. So if you have a negative value over here, or excuse me, a positive value over here and a negative value over here, if it goes from -a to a, like say this is -2 to 2, -5 to 5, then these two areas are going to cancel out because they're the same area just in different directions. So it's going to end up being 0. Now you may ask, well, why would we need to use this? It is something to know for, or something to help really with something like the sine wave. Use symmetry to find the integral from -pi to pi of sine x. Well, if you were to graph -pi to pi, remember that at 0, the sine of 0 is 0, the sine of pi is also 0, the sine of -pi is 0, the sine of pi over 2 is 1. The sine of -pi over 2 is -1. So here's your sine wave. And it wants you to integrate from negative pi to pi. Well, remember, sine is an odd function. And since you're going from negative a to a, these are the same numbers on top and bottom, this whole thing is 0. Just because I know sine is odd, and I'm going from negative a to a, the same values, it's 0. Easy as pie. Peace.